Hello and welcome back for another VMK in the C++ programming series. In this VMK I'll show you how to use a library which allows you to load PNG files. Once we have the PNG files loaded, we can go take a look at the pixel data and use them however we wish in our programs. The first thing that we need to do is download the actual source code for the PNG library which we'll be using. Using this source code we'll be able then to quickly parse a PNG file and extract all the data that's contained within it so that we can get access to all the pixels for all the images that we're working with. So to get to that library, we'll head on down to www.libpng.org. And you should get a page that looks something like this, and we're interested in going to the free reference library for reading and writing PNGs. So click on that, and that'll open up the official PNG reference library, which you can have a read through here. And basically, if we scroll down here, we can see that the current version as of recording the video is version 1.5.5. Now, when you're watching this video, there may be a newer version of the library, so some of the steps that you'll see in this video may be slightly different to make your code compile, but overall the process should be the same. So we need to download this library. We can do that by scrolling down here to the source code section, and we see that there's 3 different versions that this file exists in, and there's different sources where we can get the file from. So I'm going to grab it from SourceForge here as a zip file. So clicking on that link will take me over to SourceForge, and within a few seconds it should start downloading the PNG reference library to my computer. Once that file has downloaded, we can go back to libpng.org, and we see that the libpng library also requires lib 1.0.4 or later. 1.2.5 or later is recommended for performance and security reasons. So we do need to go and install this on our computers as well, so that we'll be able to compile the code. To do that, we can scroll down to the bottom here, and we see that there's a link to zlib, which you can also get to directly by typing in www.zlib.net. Now here we see that the current version is 1.2.5, which is the recommended version to be used, so we might as well just download this version. Scrolling down here, we see we have 3 different versions of the source code, and the format that I want to use is the zip file format, and I'll grab it from this US mirror. So again, I'm just going to save that onto my computer, and once that's all saved, let's go and take a look at those files. So here they are. I downloaded the libpng 1.5.5 and also the zlib version 1.2.5. I placed both of these zip files into a folder on my computer just under Visual Studio. And the first thing I'm going to do is open up the libpng file. Inside of here we see that there is a directory that contains all these files here. What I'm going to do is I'm just going to extract that directly into this folder that I created called PNG Loader. The other thing I'm going to do here is open up zlib 1.2.5, and within it we see that there's a folder called zlib 1.2.5, and within it is all the source code. So again, I'm just going to drag and drop all those files directly into the root here. Now, inside of libpng 1.5.5, we can see that there's a bunch of source code, and there's also a README file, which you might want to read. There's a license file, an install file, but the most important file to figuring out how the PNG library works is this file right here, libpng manual. So opening that up, you can see that there's a pretty verbose description. It's, let's see here, 4,600 lines of text describing how to use this library and all the parameters that you need to be able to load, save, anything, pretty much anything you want to do with the library is described inside of this manual. So this is a great read if you want to get more background information on how to use the library. Now everything that's shown in here I'm not going to cover in this video because there's obviously a lot more information than we need in here, but what I am going to do is go through the whole process of loading a PNG file, analyzing the data that's stored in there, and extracting the pixels so that we can see that we are correctly loading a PNG file into our Visual C++ project. So just remember, there is this file here that's very important if you want extra details on how to use the library. Now, how do we open up this project inside of Visual Studio? Well, the developers of the PNG library have created a bunch of projects for us, and inside of here you'll see there's one labeled VStudio, and inside of there happens to be a Visual Studio solution which we can use to open up. So let's go ahead and do that. Opening up the Visual Studio solution, we'll open up Visual Studio, and we can see in the Solution Explorer we have a number of projects. There's the zlib project, we have this thing called PNG valid, PNG test, we have a PNG libconf, and a libpng. That's the actual library which will compile out. Now looking at the properties here, we see that libpng, this guy is a dynamic linked library. PNG libconf is a executable that compiles out, but it's actually a wrapper for some custom build steps. So you'll notice here that when this project runs, it has a bunch of commands here that will run to execute the test and the validity of the library that gets compiled out for us. So the PNG test program, again, it has a bunch of steps here to actually execute to make sure that the library compiled correctly. PNG valid is another thing that just runs to make sure that it validates the PNG files. And zlib is the actual library which we also downloaded. And for this to work properly, if you are downloading a different version of the zlib library, you may notice that your files don't link up properly. What you can do is click on one of these files, and then going over to the Properties tab, you'll notice that it tells you where it's expecting this file to reside. So by default here, it's telling me that it should be in the zlib source directory slash compress.c. So you'll need to figure out what is zlib source directory to be able to accurately direct your project to this file. To find what path that variable is set to, we can go back here into our source files, and you notice that there is a zlib.props file. So if we open this up, we can see that inside of here it gives some parameter definitions, and the very last one is that zlib source directory. So this is the directory path relative to the solution of where the zlib library will sit. So it's located under zlib-125, and if we see here, if we go up a bunch of directories back to the root here, we see we have zlib-1.2.5. So if you did extract this to a folder that was named something different, you would have to go into here, change the properties file, reopen Visual Studio, and then it should be able to find the source here required for the zlib library. So make sure you have that set up properly. So that's the way to check to make sure that you have the zlib library set up properly so that the Solution Explorer can find it. The other thing that's very important to realize is there is a project dependencies between all of these projects. So if we right click on one of these and go to project dependencies, we see that the libpng project depends on PNG libconf and the zlib library. And if we toggle this to, for instance, PNG test, we see that that depends on these ones here. There's actually a rendering bug inside of Visual Studio here that sometimes it doesn't update this properly unless you move your cursor over them. So we can see here we have these three dependencies on that one. This file here does not have any dependencies. This one here depends on those three there, and zlib does not depend on any of them either. So depending on how those checkboxes are checked, we can go to the build order here, and we can see that the order in which things will get built in is the zlib library will get built first, then this will run, which will then follow up with this one, and then finally that one. So those are the order in which things will have to be built so that everything can compile correctly. So let's give this a try now. If we were just to select the release, there are different modes in which you can build the project, debug and release. We're only going to be using the release version of the library since that is the most stable and it's going to be optimized for best performance. We don't need to be making any changes to the actual library files, so we don't need to be doing a debug build. Also, if you read the help files for this libpng file, you'll notice that they don't support the debug versions very well. And when you are running the debug versions, you will notice that there are certain things that may be not working quite right. when I was creating these video tutorials originally, I was using the debug version and things were crashing on me and I couldn't realize why. When I switched over to release, everything was working fine. So just keep that in mind when using the libpng library. So switching over to release, we can do a build of our solution. And what that's going to do is it's going to first build the zlib library, then it's going to build the next one, which was the, I believe, the config, then it's going to build the libpng, and then once all those are done, it's going to run through these tests here to make sure that everything is actually correct. And if it succeeds, like it did here, then you should get a message saying 5 succeeded. Also, what happens here is after building the PNG test and PNG valid, it actually goes and runs that code to double check to make sure that the library is actually working as expected. So there are some testing here. It says testing libpng version 1.5.5 with zlib version 1.2.5. And the test that it does is it opens up this PNG test PNG file and then does some reading and writing tests. I'm not exactly sure what these tests do, but it does run through and at the end it says it passes. So going back into here, we can see that inside of our project we have some scripts. These are the scripts that are probably running, and there are also some of these PNG files here which we can preview, and these are the files which it uses for the test. So there's the PNG test.png, so it reads that file and then does some analysis on it to make sure that everything is working according to the way that the library was written. So now that we've run that through once, we can go into the Visual Studio project, and under the release folder we'll see that we have our libpng15.dll. That's actually what got built. We can confirm that by going back into libpng. Under the properties, we saw that under the general settings, the target name will be the project name appended with the value of 1.5 being the version 1.5. And it does compile a DLL for us. So we have this DLL. Now let's go and create a project that uses this DLL to actually load up a PNG file, which we can then analyze. Back inside of the Solution Explorer, you want to right-click and select Add New Project. And we're going to be creating a Win32 console application. And I want to be placing this, so that's the directory. And I want to call this project PNG Loader. So I'll hit OK. And under the application settings, it's going to be a console application. It's going to be using precompiled headers. And these two checkboxes are not checked. So hitting finish, this will go and create some default files for me. And let's go back inside of Windows Explorer to take a look at what it just did. So going back to the PNG Loader directory, we see we now have a PNG Loader directory in here, and there's the project files that were added and the default files that Visual Studio created for me. Now, if we were just to compile this directly and run it, by default I have it set up here so that it's complaining can't load precompiled headers. We do need to build this project first. And then if we were just to run it, I'll press Control F5, we get, oh wait a minute, I want to actually be running this project here, so I want to change this to be the default startup project, so it highlights it in black as opposed to this one here. We can't run this because this is a DLL, whereas this is an executable. So now if I press Control F5, you notice that our project runs and it displays hello, and that's just because I have this printf statement here that says hello. So our project is building and it is able to run. What we want to do is actually tie it in to this library here. Now we've already seen that once the project builds, the output goes to, going back here under lib, we have projects, Visual Studio, release, and here's where everything gets dumped out. So what we want to do is have our PNG loader file dumped out here, which it is, but what we want to do is be able to get to this DLL library, which is what we're going to be using, and we also need to get to this library file, which is the actual source code compiled for us. So when we have access to these guys, then we'll be able to load a PNG file and actually manipulate the data within there. So to make those linkages within Visual Studio, we want to go back into our project settings, under Properties, and let's see here, under C++, we're going to have some additional include directories. So these directories will tell us where the libpng file are located. Those files are with respect to where the project sits. So going back over here, so we are going to be in here. We want to get access to the libpng file, so that means we need to go back one directory and into lpng155. So we can just take this, either hard code the entire path, or I'm just going to use the relative path. So here we went back one directory and then into lpng155. So that's going to give us our additional include directory, which has all the header files and files that we'll be needing for the libpng. Also in the linker, we need to specify there's an additional libraries directory. So the additional libraries are going to be the libraries that got compiled out and they got saved. We saw here into the general target extension output directory. So it gets dumped into here. So we can either use that path there, or there's actually a shortcut that we can use to represent that same path, which is just $outdir. So that's the output directory of our project. And also with the linker, under input, we want to specify any additional dependencies. So the only additional dependency that we have is the dependency on the libpng library that gets built for us. So here we want to type libpng15.lib and then have a semicolon at the end, like so. And that should be it for the setup, I believe. So let's go and save that. Hopefully I didn't forget something. So we should be good to now start writing some code. Oh, wait a minute. There is one other setting here I forgot about. Under the general configuration, you'll notice that for the libpng file and for all the other settings, the character set that they use is the multi-byte character set. By default, the character set is Unicode, so we do want to switch that over to use multi-byte character set. The other thing you want to also double check is make sure that under C++ code generation, you have runtime library set to multi-threaded DLL. You want that to match up with what's set here inside of the libpng project. So by default here it's set up to multi-threaded DLL, so that's what you also want to have your project set at. If it's set to something else, you may have difficulties linking into the DLL, since there would be some incompatibilities there between the library files that you compiled out for the PNG library and the files that you're using to compile your code with. So make sure that those two things match up. Okay, I think that's it for the setup stage. Now we can actually get to the coding stage. To use the libpng library, we do need a header file, since the header file exposes all the functions that are available within the library. The header file is located under, let's go to add existing item, and we want to go back one directory into the libpng155 directory, and here it is here. It's png.h. So you want to hit add, and inside of here you'll see you have all your standard definitions for all the functions, all the structures, and everything you'll need to be able to use the library. So I like to add that into the project, and then inside of stdafx.h you'll want to add and include png.h file statement here so that the project knows that that's where the library header is located. Once you have that set up, we can go back to the C++ file now and start writing some code. Now what we want to do is be able to load a PNG file and analyze the pixel data that's contained within it. So what I've done here is I've went into Photoshop and created this sample image. This is the image that we'll be using to test to make sure that our program is working and is able to read these pixels out. Now, I've structured these in a special way. You'll notice that this is an image that is 4 pixels wide, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's 9 pixels tall. The top left-hand pixel is a completely red pixel. If you notice, if you look up here in the top right-hand corner, it gives you the red, green, blue values as well as the opacity value. So for the red one, you notice it's 255, 0, and 0, indicating that it's red. The green one is 0, 255, 0. Blue is 0, 0, 255. And then we have cyan, which is 0, 255, 255. Magenta, which is 255, 0, 255. Yellow, which is 255, 255, 0. White, which is all 255s. Black, which is all zeros. And then lastly, we have this one here, which is a completely transparent pixel, meaning it doesn't have any color with it, and the opacity is set to 0. What I then did is I took all those colors and I moved them over and I decreased the opacity by 25%. So you notice that in this row, it's the exact same colors, same values for the colors, red, green, and blue, but the opacity value now over here says that it's 75%, whereas these ones here are all set to 100%. So you see these are 75. Then the next column over, they're all set to 50%. And the last column, they're all set to 25%. I did this specifically to make sure that we have the same value for the color, but different values for the opacity going horizontally across. And going vertically, we have different colors with the same opacity level. Using this test image, we'll be able to analyze to make sure that we can actually see that the PNG library file is correctly reading out each of these pixel values. So I saved this file out, and I'm going to place it right here. So here's our test image.png, and again, I'll just preview it to show you that sure enough, there it is. It's really small, so we need to zoom right in, and we can see there's the values that we were just looking at inside of Photoshop. Okay, so I have the image here saved under the PNG Loader directory, which happens to be located with respect to the project many directories back. So if I go back into Visual Studio Release, this is where our project will be running from. So if I want to actually open up that file, we need to go back 1 directory, back 2 directories, back 3 directories, back 4 directories, and then into the PNG Loader directory, and sure enough, that's where our PNG file is located. So knowing that information, we can go into our source code here and specify where this file is with respect to where the executable will be running from. And that's what we see here. I'm going to create a constant std string for the file name, and it's going to be back 1, 2, 3, 4 directories from our current location inside of the PNG Loader directory, and there's the test image.png file that we're going to be using. For the compiler to recognize what this is, we need to go back inside of stdafx.h and also include string. We should go inside of stdafx.cpp and compile that. Once we have that compiled, we can go back into the PNG loader and notice that the red squiggly is gone, because now it recognizes what a string is and it's able to declare this variable for us. To load this PNG file using the PNG library, we need to keep track of 2 things. To make the code a little bit more modular and easier to use, I decided to create a structure called PNG file, which contains those 2 objects that the PNG library uses. So the library uses this thing called PNG struct and PNG info. Both of these will get initialized and used to hold all the pixel data that's stored inside of our file. Also, I dumped in here a pointer to our file so that we can open up a file and use it as we need throughout our project. I put all these things inside of a structure because inside of the constructor we initialize everything to null, but then when this object goes out of scope, we'll automatically clean everything up inside of the destructor. So if the file pointer is not null, meaning we already opened a file using this file pointer, then it will automatically close it for us And if we initialize the structure, then we will have a non-null value for the structure, which means we can then go and clean things up. Depending on whether we opened up the PNG info, we may or may not need to clean that up. So the way that we clean things up in the library is we use this function called PNG destroy read struct. And if we have both the structure and the info, we pass both of them in like so, with the third parameter set to null. Otherwise, we'll just pass in the address of the structure like this, and then null for the other two parameters to just clean up the structure. So I'm going to be using this structure here to keep track of our PNG file that we load into memory. I'm just going to create an object here called PNG, which is one of these structured objects. Okay, so to start off, let's test to make sure that this file actually exists on our hard drive and we didn't get this path incorrect. To do that, we need to call fopen on the file pointer that we have stored inside of that structure. And the file name that we're going to try to open is this guy here. We're going to be opening it up as a binary file to read in. If this succeeds, then it's going to be equal to 0, so we'll continue on down below. If it fails on us, then it's going to return a non-zero value, so we'll display a message saying this file could not be opened, and then we're going to return 1. Now, we don't need to do anything beyond that because our PNG file structure will automatically clean up our file pointer when it gets destroyed when it goes out of scope. So let's go and build this. And just for testing's sake here, I'll put printf file open and give this a run. Control F5, and we see that this file here could not be opened. All right, so that means we have either the path set up wrong or project settings set up incorrectly. To figure out which of those two options it is, we can open up a command window and go down to the output directory. So in here, we should see our project PNG Loader.exe. If we run that PNG Loader, if this runs correctly, that tells us that the code is correct, but Visual Studio is set up incorrectly. If this fails, then that tells us that the code is incorrect and Visual Studio may or may not be set up correctly. So running through that, we see that the file does open successfully, which does confirm that Visual Studio is set up incorrectly. So right-clicking on PNG Loader, going to the properties, let's quickly take a look at the general information. So the output directory is here, and when we're debugging, where are we currently located? So the working directory is the project directory. Okay, so that's the problem. We want to change this to be located at the output directory. Now let's go and Control F5. Notice now we have file open, press any key to continue. So now we're actually able to successfully run the code because we're located in the right spot with respect to where the executable is, so therefore it's able to find this PNG file. So we know that we can open up the file. Now what's the next step that we need to do? Well, we need to make sure that the file that we're opening is actually a PNG file. If it's not a PNG file, then there's no point in trying to parse it and extract the pixel data because it is not an image saved as a PNG file. To confirm whether a file is a PNG file, each file is pre-appended with a special header. If we open up our image file in a hex editor, we can actually look at the bytes that are located right at the very front of the image. So I'm just going to use this file called free hex editor neuro. And in here we can see that the very first string of bits here show that it has 89, 50, 4E, 47, 0D, and so on. And that converts over to something that says PNG with some other character bits which are not ASCII text. That is actually hard-coded to be specific to all PNG files. All PNG files should have this pre-appended value here, PNG, to let you know that it is a PNG file that you're opening up. Inside of the PNG library, there is a function that you can use to confirm whether the first bit here tells you if it's a PNG file or if it's not a PNG file. By using the following chunk of code, we can test to see whether the file is actually a PNG image. So first thing we need to do is specify how many bytes we want to check to see whether it's a PNG file. You notice that there are some bits here which clearly state it's PNG, but there's also all these other bits. By definition, there's actually a certain number of bits you can check. I don't remember exactly off the top of my head, but if you look in the user manual under this function here, it will tell you what is the maximum size that you can actually compare. Maybe it actually says in the help documents as well. Let's open up the help docs. It says here, checks whether the supplied bytes match the PNG signature. We allow checking less than the full 8-byte signature so that these apps blah blah blah. So basically it tells you you can check the first 8 bytes or you could check less if you wanted to. But if you try to check more, then it's going to fail on you. You'll notice here that there's a error message that gets printed out if you are trying to do more than 8 bytes in your check. I've declared this variable num header bytes, which was declared up here at the very top. So that basically says I want to check the full 8 bytes. So I need to create a byte array that contains 8 bytes. We're going to read from our file a full 8 bytes stored inside of this array here, and then we're going to pass that into this PNG sig compare function call. This basically checks that header against the expected header that a PNG file should have, and if it does match, then it will return to us down here saying that this is a PNG file. If it fails on us, then it's going to return an error message saying that this file is not a real PNG file, and then it's going to quit. So let's go and, well, let's type in some code here. Printf, this is a PNG file. And Control F5, give this a try, and we see that this is a PNG file. So that tells us that this file here that we're loading in, sure enough, is a PNG file. Now to double check that this code actually does correctly work, what we can do is go back inside of Photoshop here, take that exact same image file, and let's save it out as a JPEG. So there's our image. I'm going to hit save, and we're located inside of PNG Loader. So in here, I'm just going to save my testimage.jpg. Going back into our directory, we should see we have testimage.jpg now. If we preview that, we have our image. There it is there. And we can actually open this up inside of our hex editor as well. And we notice that the first string of bits here are different than in the PNG file. In the PNG file we saw we have PNG and then all these bits here. For a JPEG we have something different, and you notice it does say JFIF, which is the specific header that is used for JPEG. So now if we go back into our source code and try to open testimage.jpg, Control F5, we notice that now it displays an error message saying that that is not a real PNG file, and it quits out on us. We could also do another check. Let's say we have something called testimage.gif. Even though I'm not going to use a GIF, what I'm going to do is going to take the actual PNG image, save it out, and rename it to be testimage.gif. So even though I'm saying it is a GIF, it's actually saved as a PNG file. If I try to run this set of code, you notice that this says this is a PNG file. So it is able to recognize, even though the extension doesn't match, it still knows that it is a PNG file because it's not looking at the extension, it's actually looking at the bytes, at the byte array stored inside of the header of the file to determine what kind of file type it is. Okay, so let's change this back to PNG, since that's what we're going to be using. Now that we've tested and made sure that the file actually exists and it is a PNG file, we can start initializing our structures here, which will be used to parse out all the pixel data stored inside of the PNG file. Okay, so first thing we do is we need to call this function called PNG create read struct. What that's going to do is it's going to return to us a structure, and we need to pass in what version number we're using, and these other parameters we can set to null. Again, if you want the details of what each of these parameters do, I recommend you go to that text file which contains the manual, and it describes in more detail on how to use each of these. You can also go into the declaration for each of these function calls. It gives you in the comments a little bit of description of how to use these and what you'd be using them for inside of the library. So once you have the structure, if it succeeds, we'll go down below. If it doesn't, we'll just say we could not create PNG structure, and then we're going to return. Once we have the structure, we need to go and create our second object, which was that p-info. Remember, we had the structure and the info. You need both of these objects to be able to parse a PNG file. So we get the info by calling PNG create info structure. We pass in the structure we created up above, and that will return to us a pointer to the info structure. Again, if this fails, we're going to return an error message. Otherwise, we'll go down below. Now, what we need to do next is prepare our structure for error handling. Once we start reading pixel data out of our structure and storing it inside of our info, we may run into cases where we have corrupted data. In those cases, the library file uses a error handling technique which needs to identify how things are structured within our initial setup. So to prepare for that, we need to call this function called setJump. Here we pass in the result from calling the function png jump buffer. So call that. If it succeeds on you, go down below. If it fails, you're going to return an error message saying cannot init the error handler. So then we're done. Okay, so then we're down to here. Now we need to tell the PNG library which file is it that we want to be working with. Well, we already opened up the file up above, and we stored the file pointer to it inside of this structure here. So we can get to that file pointer here, and we can tell the PNG library all about it by calling png init io. So initialize the io for our structure, and here is the pointer to our file that we're going to be working with. Lastly, before we actually start reading the pixel data, we also need to tell the PNG library how many bytes of this file pointer have we already read. So because we did a check up above here for the header, we already previously called fread on our file pointer, and we read this many bytes of data out of that file. So what that means is the file pointer has already incremented by, what was it, 8 bytes? So down here, we need to tell the library file that we've incremented by 8 bytes so that when it starts reading data out of this file, it knows what state it should be in. So here we pass in how many bytes we read, here we pass in the structure that we're using, and that's the function call that we use. You'll notice that pretty much all of the PNG library function calls require either a structure or the info parameter to be passed in as the first parameter, since that's the linkage between initializing the library and actually using the library. So once we get down to here, we're now ready to read the data that's stored inside of the PNG file. Now there's two different ways that we can do this, which are described fully inside of the PNG library manual. I'm only going to be using one of these techniques, but if you want to use the other technique, then have a look in the manual for the details of which functions to call and in which order and what all the parameters do. So to read the image data from the file, so I'm going to be calling this function called png read png. We pass in the structure, we pass in the info, and then we pass in a bunch of flags to indicate how we want to parse the data that's stored inside of that file. PNG is a compressed file format, so certain pixel data may not be exactly a one-to-one mapping of what it is you want. When you are using the data that you're extracting, you want precisely what is the red, green, blue, and alpha value of each pixel. But in a PNG file format, because it is compressed, you don't have exactly that data. It has to be converted over to be able to extract those individual pixels. In that conversion process, you can choose how it is that you want to convert the pixels over. So that's what all these flags here are for. If you want a description of what each of these do, we can go through here and take a look at the different transformation options you have, and it doesn't look like it describes them here. So let's open up the help file. We do a search here for PNG transform strip 16. So it tells you here what that flag does. If we go back and take a look at transform packing, we can do a search for that, and we can see here, here's the table I was looking for. So the high-level reading interface, this is the interface that we're using. You pass in one or more of these flags, and each of them will tell you how it is you want to handle the data. So PNG transform strip 16 will chop 16-bit samples and make them 8-bit, and this is a little bit faster than scaling them since we don't actually have to perform a scaling operation. Transform packing will expand 1, 2, and 4-bit samples to be a byte. Each pixel can be represented in many different formats depending on the color codes that you're using. So by specifying packing, you are basically expanding them out to a default format that uses a full byte for each pixel, which is what I'm going to be using. What other flags do I have here? Transform expand. What that does is it performs the same operation as set expand. So if you want to look at what set expand does, read through the documentation. And then finally, transform gray to RGB. If you have a grayscale image, meaning it's only white, black, or somewhere in between, then your RGB values will not actually be saved correctly. If you use gray to RGB, what that's going to do is convert your gray values to appropriate RGB values, so your array will be larger because you're now storing RGB for each pixel as opposed to just one value for each pixel. But then it's a lot easier to analyze what is each red, green, and blue value if you are going to use these for OpenGL with full color support. So that will do that expansion for you automatically. So there are some other ones in here if you want to read about them, if you are interested. But if not, these are the standard ones that you can use, and that should be good enough for you to actually load a file into memory. Once we've loaded the image data, there's going to be information stored inside of this structure, which we can extract information about the image. So for instance here, we can show the image attributes, such as what kind of color we have stored inside of that image by calling PNG get color type. We pass in the structure, we pass in the information about our image, and it's going to return to us a color type. Then if our color type is equal to color type gray, then I'll display a message saying that this is a grayscale image. We could also have GA, which is a grayscale image with an alpha channel. We could have a palette image. We could have an RGB image. We can have an RGBA, which means red, green, blue with an alpha channel. Or it could be some other type, which I'm just going to group here as an unrecognized color type and then specify the color type. You might get this if, for instance, you're running a newer version of the library, the PNG library that came out after this video came out, in which case they might have added a new different kind of color type. So if you want to use that specific color type, you could just basically take a look at the new declaration that you would have declared for you. It will be located in this grouping here somewhere inside of that png.h file. And it will tell you specifically how it is that that data is stored inside of the file. Okay, so let's go and save this and run our program, Control F5. We can see that the sample image that I'm using is stored as an RGB color image with an alpha channel, which is reassuring because we saw in Photoshop here that we are using RGB, so we have full color, and we also have varying alpha values, which means that we should be saving an alpha channel within our file. If we are not getting that, then that means that when we saved our file, we either disposed of the alpha channel, meaning we only have the colors and no opacity information, or there's something else wrong with the PNG file. So make sure that what you're expecting is what you're getting from the PNG library. In addition to the color information about the image that we loaded, we also have other information such as the width, the height, how many channels there are, how many bytes there are per row, and each of the individual pixel data itself. So to begin, let's take a look at the width and the height. To get the width and the height of the image that we just loaded up, we would call PNG get image width or PNG get image height. So we'll call both of those, store the variables here, and then display them to the screen so that we'll see how many pixels wide and high our image is. Number of channels will tell you how many channels there are per color. So here we call PNG get channels. Again, we pass in the structure, we pass in the info, that's going to return to us number of channels, and then number of bytes per row. This is information that we need to know if we're going to be extracting the pixel data. So here we call PNG get row bytes. Again, we pass in structure, we pass in info. This gives us a number which we're going to display onto the screen. So pressing Control F5, let's take a look at our image. We see that it's an RGBA image. We have 4 pixels wide, 9 pixels tall, which is what we saw in Photoshop. We have 4 colors per channel, so that's good because we have RGB, that's 3, plus the alpha, which is our 4th value. And then we have 16 bytes per row. What does that mean? Well, that tells us that because we have 4 colors per channel and we have 4 pixels per row, if we multiply those two together, you get 16. So that's where our 16 bytes comes from. This would be different if you have a different kind of colored image. For instance, if you didn't have an RGBA image, you might have a grayscale which you did not convert over. You may have a different number of colors per channel, which means that you would have a different number of bytes per row. You need to know how many bytes there are per row because as you start extracting the data from the array that you're going to see in a second here, you need to know how far across you need to go before you start your next row. So now let's take a look at how we can go and extract each of the rows and each of the pixels in each row to display on the screen to see whether we're actually extracting the correct data from our file. Okay, so here it is. We call a function called PNG get rows, passing in the structure, passing in the info. This is going to return to us a pointer to all of our pixels within our image. We can then iterate through y and x. So we're first going to be iterating through x. So we're going to be going across on the image, and then we're going to be going down in y vertically to get all the different colors that are stored there. So on the screen here, I'm going to display what is our current x and y coordinate. That will tell us which pixel we're looking at. Then we're going to take a look at all the channels. So we had 4 channels per color, so we'll see RGBA. All that's going to be displayed on the screen with a comma beside each of those. And for each value, we can extract the pixel value using this formula here. So first we have y. This tells us which row we're in, and then we have the location within that row that we're extracting the pixel for. So x times the number of channels will tell us exactly which pixel we're looking at, and plus c tells us which element within that pixel we're trying to extract. So whether it's the red channel, the green channel, the blue channel, or the alpha channel that we want. That's going to return to us a value which we're going to display to the screen to compare against what we saw in Photoshop. Then all this other stuff is just formatting to make it pretty on the screen. So Control F5, and let's take a look at the results here. 0, 0, this is the very first pixel in the top left-hand corner. We see we have red, green, blue. So red is 25500, alpha is 255. So coming back to Photoshop here, let's put these side by side and see whether these make sense. Well, this is the top left-hand pixel, and we see, sure enough, red, green, blue, we have 25500, and opacity is 100%, which is equal to 255. So that's that first pixel there. Then we go over 1, so we have 1, 0, which is this pixel here. We saw we have the same color, red, green, blue, which is red, and now the alpha value is 191. So if we take 255, multiply it by 75%, we see we do get 191. So that's where that 191 comes from. Half of 255 happens to be 128, so that's the next value over. And then 25% of 255 is equal to 64, so that's where that value comes from. So we see this whole row, that top row, is all red because it's red, green, blue, so 25500 for all of them. And the only thing that's changing is the alpha value from 255, 191, 128, and then 64. Moving downward, we see the different colors. So the one down here is green, so 02550 with opacity of 255. Next one is blue, 00255. We saw here 00255. And then we have the cyan, magenta, yellow, white, and black. So here's white, 255, 255, 255 with an alpha of 255. So that's that one there. Black is all zeros with 255. And then we have these pixels down below here, which are no color, but full opacity. So the way that that was represented is we actually saved white as our color with 0 for the opacity value. Those pixels are completely transparent and you won't actually see this white color stored there. So there we go. Our PNG library is effectively loading our files into memory, and then we can extract all the pixel data that we want from our pixel array, and we're displaying it to the screen to confirm that yes, we are able to load a PNG file, and yes, we are able to extract each of the pixel elements within that image. If you have any questions about this VMK or any other VMK for that matter on the website, click on the thread link and post your questions there, and either myself or one of the other members of the website will hopefully post a solution for you.